In this video, I'd like to demonstrate the integration between LucidLink file spaces and Wasabi object storage. I have a Wasabi environment where I have 5 buckets already created. I have downloaded my access keys, my credentials, so I have them ready to go. So I'll go ahead and create a file space called Wasabi, choosing your storage and selecting the Wasabi tile. I've got 2 regions to choose from. I'm going to select Ashburn and specify next and create file space. While the file space is being set up, I'll give you a tour of our environment. We have a Windows machine that I'm currently on, a Mac OS machine and a Linux machine. I'm going to use a fairly simple data set, which is a text file that contains 2 megabytes of content. So if we look at the size of the file, it's 2 megabytes of content, and that'll demonstrate our unique block level data layout for random access streaming out of the object store. So we'll go back, and our file space should have completed setting up. Which it has. So we're now ready to initialize the file space. To initialize the file space, we're going to need the LucidLink client installed. I already have it installed on my Windows, Mac and Linux machines. So I'm going to put my access key in for my Wasabi object store and put in my secret access key and choose a shared secret. My shared secret is going to be my encryption master key, which we stretch to AES 256. So I'll choose something secure and initialize. So once we've initialized, we'll be able to open the file space. Now remembering I'm on my Windows machine now, so I'm going to create a folder called Windows, and I'm also going to add the data file, the 2 megabyte data file, by copying and pasting into my file space, and we can see we've uploaded a small amount. We were talking about 80 to 90 kilobytes at that point. Remember, this is a 2 megabyte file. So when we send and work with the data layout, we're compressing at the client side and encrypting at the client side and sending the data in our block level layout into the object store, which will consume the amount of space in our data layout which it requires after the data's been encrypted and compressed. So if I press refresh now, we should see a new bucket, which we have wasabi.filespace and a globally unique identifier created a couple of minutes ago. If we open up, we'll see objects. Now we put 2 megabytes of data in, however we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 kilobytes, so 100 kilobytes of actual data in the data layout. Now, to demonstrate our garbage collection, I'm going to now delete this 2 megabyte file, and we'll wait for garbage collection to collect these expired objects in the data layout. In the meantime, I'm going to leverage my Mac OS machine and join the same file space of Wasabi 1, 2, 3, 4, 5. And now we have a Mac OS machine who's going to liaise with the file space the way it natively does. So we'll see that when we create a new folder, it'll propagate and synchronize the metadata across to our windows. When we name that folder, it'll propagate that name change. If we join also our Linux machine to the same file space, we will see Linux will have a mount point natively injected into its file system. And we can create a folder which will also propagate, and we can call that Linux, which will also propagate. If we were to create a new document, empty document, and call it data.txt, we'll see that propagate. If we open that data with LibreOffice, we'll see that we'll be able to add something to it, close and save. And then if we look under Windows, we can open up in Notepad and we see something. We can add something else. We can save that, close. We can go to Mac OS and open with text editor, and we see the additional data. So we're collaborating out of the same file space, and we see that data across our Windows, Mac and Linux platforms injected into the file systems of each OS. So I'm going to fast forward a few minutes so that we can have a look at garbage collection, clearing up these expired objects. Before we do, we'll press refresh to see where we're at in the object store with objects. So now we can see the additional objects that make up our file space, and we'll wait a few minutes for these 1143 objects to disappear through garbage collection. So now that 10 minutes has elapsed, that should be sufficient time for our garbage collection to clean up the expired blocks of the 90 to 100 kilobytes that we uploaded in the 2 megabyte file that we wrote to our file space. I'll press refresh now. We should see that the objects that relate to the amount of data that's in the file space reflected. If we look back, we've got the files and the folders that we've created. We've demonstrated that LucidLink integrates with Wasabi, writes natively as a distributed log-structured file system into the Wasabi object store, performs compression, encryption, garbage collection across OS clients of Windows, Mac, and Linux. Thank you.